So tonight, I want you to look up at the stars, and I want you to remember that the atoms in those stars, well, the atoms in stars, are actually the same atoms in you. So the atoms inside you are the same atoms that were inside stars that existed billions of years ago. Same atoms. That is just mind-boggling to think that we are actually rock stars. You are a star. So if you ever have doubts, you feel like a failure, you don't believe in yourself, think about it. You're really a star. So you are made of the same atoms that were in stars billions of years ago. And the Big Bang, the universe got started, and all this matter and energy is compressed into a small space. So all that matter and energy compressed into a small space, increased density, there's a lot of pressure in there. To release that pressure, we have an explosion. Woo! A Big Bang. And that explosion caused the gases to spread out through space. And it's still spreading today, so the universe is expanding as we speak. After that Big Bang, in those gases, subatomic particles were actually made. So protons, neutrons, electrons, they were made from that Big Bang. They're floating around in space. So we have a proton and a neutron. These are parts of an atom. They're spinning around in this hot ball of dense gas. So these hot, dense balls of gas are floating around in space after the Big Bang. And those dense balls of gas attract other dense balls of gas, and then those balls of gas attract other dense balls of gas. Now pretty soon you've got a big ball of dense gas that's moving around. So inside that gas we've got these subatomic particles, protons, neutrons, electrons. So we'll say this is a proton, this is a neutron. When they're flying around in space, like this, they're just going, they're going wild. They crash, they're gonna crash. So these protons, neutrons, they come together because of gravity. So remember, gravity is the force that attracts two objects. So it's an attractive force between two objects. In space, the force of gravity really causes the formation of atoms. Because we have protons, neutrons come together, electrons come in, join in, and you've got an atom. So atoms are made. And the first atom to be made is hydrogen, because it's the lightest. Hydrogens are formed. Yeah, so hydrogen was formed. This is one hydrogen. This is another hydrogen. These were formed now. These are two atoms. Now, these hydrogens are floating around in space. It's very, very hot. It's like 1 billion degrees heat, very hot. Then what happens is there's some crashing going on, like a car crash. And these are actually light bulbs, so I really don't want to crash them. But gravity again, force attracts the objects together. So if these are flying around in space and they come close in contact, they're going to attract each other. Okay, when these two hydrogen atoms combine, we call that nuclear fusion. Nuclear fusion. It's a combination of atoms. Combination of two atoms to form a different type of atom. So in this case, hydrogen atoms combine to form helium. So helium is a little heavier than hydrogen. When it does that, there's a lot of energy and heat involved. So a lot of light is produced, a lot of heat. So heat and light are forms of energy. So in this process of nuclear fusion, energy, lots of it, massive amounts of energy is created in the form of light and heat. And this causes the stars to shine. So shining stars at night would not happen without the force of gravity. So gravity causes nuclear fusion, which happens in the stars we see at night. And this relates to chemistry because this is where all these atoms we're going to be talking about came from. Came from stars. And stars, when they make helium, two heliums can combine and form larger, heavier elements like carbon, oxygen, nitrogen, all the way up to iron. So when you get to iron, there's no more fuel for the stars. The gas runs out. Iron is the most stable element there is. So once the gas of hydrogen, oxygen, carbon, nitrogen, that's all burned up, the star would be considered to be dead. It dies. It ran out of gas. So the force of gravity then sucks in that star. The gravitational force sucks in the star, collapses. So that star collapses in on itself. And when it does that, it becomes very dense, very pressurized. And then that pressure, high pressure, is released in the form of a supernova. So a supernova is really like the death of a star. And this is what's going to happen to our sun, since our sun is actually a star. Our sun is 5 billion years old, and it's going to probably be around, scientists estimate another 5 billion, but after that it's going to die out, become a supernova, because it will run out of gas, will run out of fuel. So this is just wanted to show you that how awesome stars are and how it relates to chemistry, because this is where all these elements and these atoms come from.